Hello, everybody. This is Billy here. I heard that some of you were confused from the video that I had you watch on Friday, so I also wanted to make this video to walk you through the examples, and hopefully this second time around with me explaining will help a little bit. I heard that the other lady may have spoken too fast, so I will try to take it slow, but also address whatever concerns you may have missed from the previous video. So, the point of today is that we are not factoring like we were in 8.5, where we had a trinomial and we factored it into two parentheses like that. So that was a little bit easier. We just figured out what two numbers multiplied to get the last term, but added to get the middle term. These look a little bit different. So for example 1, you'll notice that there are two different things here separated by the subtraction signs. There's this 2x times x plus 4, and then there's this 3 times x plus 4. What they both have in common, which is what factoring is all about, what do they have in common, is this x plus 4 part. So what that we can do is factor that x plus 4 out, and then just in parentheses put what is left. So imagine that the x plus 4 went away. In this first term, or this first set, you would have 2x. And then in the second term, you would have a minus 3 if the x plus 4 went away. So cover up the x plus 4s after you factor them out, and then rewrite what is left. And then that's all for that one. Okay, for the next one, for both of these that are separated by this addition sign, so there's this set and there's this set, they both have a y minus 2 in them. Okay, so you'd factor out the y minus 2, cover it up, and then write what's left. So in the first term, we have 3y squared, and then in the second term, we have a plus y. Okay, if there's nothing there, like example 3, then you put a 1 there. So you would do 3y squared plus 1, or minus 1. Okay, so that's example 1. And I think I can keep going. I'm going to pause for 1 second so I can write the other examples down. All right, so to example 2. Up here I have, you can't see that too well, but up here I have written an example like we would see, like a classic example from 8.5. You have a quadratic trinomial, 3 terms, and then you would factor it as x plus 2. I'll write that down here. And x plus 4. Okay, these problems in example 2 look different because there are 4 terms. So when you have 4 terms, we do this thing called factor by grouping. Factor by grouping. Okay, so you look at the first 2 terms, you group those 2 terms, and then you group the second 2 terms, and you ask yourself, what can I factor out of both of those? So the first term, you can factor out, the greatest binomial factor would be x squared. Factor out an x squared, and then you're left with x plus 3. And the second group, you can factor out a 5. And what you should see is that you're left with the same thing that you were from the first term. If you're not, then you know you did something wrong. So then what this looks like is an example from number 1. So in this group, we can factor out this x plus 3 because they both have an x plus 3. Once you're done with that, then you would write what's left. So if you cover up the x plus 3, you're left with x squared plus 5. And that would be the answer for that one. For part B, once again, you have 4 terms. You can group the first 2 terms and the second 2 terms. From the first term, you can factor out 1y. After you factor out the 1y, you're left with y plus 1. From the second group, you can factor out an x. And you should be left with y plus 1. So let's see if we are. Y. We factored out this x, a 1 is left. So we are. But we're not done yet because then you have to factor out the y plus 1 term. So y plus 1 times y plus x. So in example 1, there was only one step to factoring, but in example 2, there are 2 steps to factoring. Okay, so let me pause the video so I can write down example D and E. So in example D, if you were to group these first 2 terms, so these two terms and these 2 terms, in these 2 terms, there's nothing you can factor out. There's nothing that's in common between x cubed and 6. So what we could do is rewrite this polynomial in standard form, so from highest to lowest power. So let's rewrite this as, let's put the negative 2x here. Well, basically, we're going to switch the negative minus 3x squared and the minus 6. So minus 3x squared and minus 6, okay? Then we can take these 2 terms and group these 2 terms and factor out an x squared from here. And then we're left with x minus 3. And over here we can factor out a 2, and we're left with x minus 3, okay? Remember, these 2 things, what you get in the parentheses should be the same. And if they're not, then you did something wrong when you have these 4 terms. So then factor out the x minus 3. So x minus 3 times x squared plus 2. Okay, and just remember, you can also write this as x squared plus 2 times x minus 3. You can switch the order of these around. That's fine. Okay, for the second one, we have the same situation. So what we can do is we can either switch these 2 terms or these 2 terms. It doesn't quite matter. You should get the same answer both ways. I'm going to switch the first and the last terms. So this will be 2y and this will be 2x. So if I group the terms, in this group we can factor out a y, and we're left with y plus 2. In this group we can factor out an x, and we're left with y plus 2. Okay, so then your answer would be y plus 2 times y plus x, because you can factor out the y plus 2 parentheses. Okay, so I'm going to pause the video and put example 3 on the board. So in part A from example 3, this looks an awful lot like the problem that I showed you up here. That's a typical problem. However, what you can see is that the a is not equal to 1, which normally we don't know how to factor that. We would use our calculator for that. And the highest power of x is a 3. So this is not a quadratic trinomial like we're used to. But if you notice, each of these 3 terms has 2 things in common. They both have a 4, and they all have a 4, and they all have an x. So what if we factor that out? Could it end up looking like something like this that we could factor? Actually, yes. So let's factor out the 4x. And we would be left with x squared minus 11x, and then plus 24. Okay, do you know any numbers that would multiply to 24 but add to 11? 3 and 8. Since the 11 is negative, you would make it minus. So 4x squared, set up your 2 parentheses, 8 and 3, minus and minus. Okay, you're not solving, but if you were, you would set this equal to 0. Your answers would be 0, 3, and 8. Let me pause one. Okay, so in part B, likewise, you can factor out. First step is to ask yourself, can I factor something out? And yes, you can factor out a 2h squared. You'd be left with 25h squared. And remember, this would be minus 1. If we factor out the whole thing, it would be minus 1. Then what you have to recognize here is that the result that's in parentheses is a difference of squares. So that's the trickiest part that a lot of people miss, is that 25h squared minus 1 is a difference of squares like we learned in 8.7. So you have to factor that. Okay, so set up your 2 parentheses. Remember, one gets a plus and one gets a minus, and then you'd put the square roots of each of these in the parentheses. So 5h, 1, 5h, and 1. And that would be the final answer for that one. I'm going to pause the video so I can write example 4 on the board. All right, so example 4, part A and B is kind of like example 3, part A. But now, instead of just factoring, we're going to factor in order to solve. So in part A, first of all, we need to get it to look like part B, where the one side is equal to 0. That's the first thing we need to do. So let's move the 24x over. And actually, instead of rewriting the whole thing, I'm just going to change this. If we're adding it, then it would be plus 24x equals 0. And the reason why I said it looks like example 3 part A is because you have the 3 terms, but the highest power of x is not 2, like it normally is in a problem like this, and the a is not equal to 1. So you might think, well, I can't factor this. I would have to use my calculator. But if we factor out what's in common between all 3 of these terms, since they all have an x and they all have a 3, then we would be left with something that we could factor. So let's do that. So factor out a 3x, and then you'd be left with x squared plus 6x plus 8. And look, this is actually exactly like the problem that I wrote on the board. So the factors of 8 that would also add to 6 are 2 and 4, both plus, because your both terms are positive in the middle. So 3x, x plus 2, x plus 4. Now, if you're solving, there are 3 different factors, okay? 3 factors here. So we would set each factor equal to 0. And let me underline those 3 factors just so it's clear. It's 3x, x plus 2, and x plus 4. If we set this equal to 0, then we just get x equals 0, because if you divide by 3, 0 divided by 3 is 0. So x equals 0 is one answer. For this one, if you set x plus 2 equal to 0, you would get x equals negative 2. And then this one, you would get x equals negative 4. Okay, I challenge you to take this original problem and type it in your calculator. You'll find something interesting, okay, something that we haven't studied yet, not your normal quadratic parabola, okay? It actually has 3 zeros. It crosses through the x-axis 3 times. Okay, a very similar situation with part B. So first of all, to factor, we notice that all 3 terms have a w in them. So let's factor out the w. We'd be left with w squared minus 8w plus 16 equals 0. Now, can you think of 2 numbers that would multiply to 16 but would add to 8? 4. And since the 8 is negative, they would both be minus 4s. So w minus 4, and w minus 4. So once again, we have 3 factors, w minus 4, and w minus 4. So this is still would still look like a graph like this, except that it actually only will cross through the x-axis twice, because there are only 2 different solutions. W equals 0 from this factor, and w equals 4 because these factors are the same. They give the same answer. So there's actually only 2 answers for this question. So this would be the correct factoring for this. On the homework, you might also see on the homework key, you might also see that I write it as w times w minus 4 squared. Okay, either one of these are fine. This is not necessary to write it like this way, but you can. Okay, and then these would be your 2 answers. You only have to write the 4 once. Okay, so that's all from 8.8. I hope that helped. If you were struggling on the notes from the video that I shared with you, and we will check in on Monday with how you're doing and go over whatever problems you want. Okay, I'll post more on the update on Polaris about what to expect with the homework and the exit ticket. All right, see you guys later.